Welcome back. We looked at that simulation last class period with the coin. This one was a different class period that I think I snipped and put on here just to kind of reference. I think this one I did multiple classes. It looks like I have 1,841 different simulations of flipping a coin 20 times and recording the outcome. So we looked like our mean was 0.502, roughly 50%. SD stands for standard deviation. That's what we're going to talk about today. We can see here we had, looks like one got two tails out of 20 flips. That's pretty cool. Not very likely, not very common. 11, 12, 13, 14, 15, 16, 17 out of 20. So also not very likely, but this is how the normal distribution appears like naturally in places. Um, and it's pretty fascinating. So the normal distribution, we have the same shape, different spread. All normal distributions have the same bell shape. What changes is, the mean is the center, the standard deviation is the spread. And so that's why I said when we have something that is, it's approximately symmetric, we use the mean. So we're going to talk about with normal distribution, mean over median when it comes to the normal distribution. And the standard deviation, we're going to look at as the spread, not the 5-number summary. You guys are going to tell me the 5-number summary and the spread because you're going to be dealing with your data more than likely should be considered normal. So what measures spread here? The measure of spread for the normal distribution is called standard deviation, and it tells us the average distance data values are from the mean. And you'll have, once you calculate that, if you have a smaller standard deviation, that means that your data is more consistent, it's more pushed together, and a larger, the data is less spread out from the mean. A larger standard deviation is the opposite. Data is less consistent, and the data is more spread out from the mean. So if you look at the more narrow one, we can see that the data is kind of clustered closer together. That would have a smaller standard deviation than the short, fatter one, where it's more spread out. And we should be able to see that from looking at that. So now we're going to calculate the standard deviation using Google Sheets for the following data set: 2, 1, 3, 2, and 4. And enter data into a blank Google Sheet. Let me see how far I have. Okay, so this is our formula for standard deviation to show you what that looks like. It's ST diva equals ST diva and then our range. So let me go over here and then we're going to record that in our notes. So let me go back over here. I'm just going to go, so this is a copy of my heights. So I'm just going to go on this thing real quick and type this in. So I already have my answer. Y'all should be able to see that. Like I have my answer pulled up. We should get 1.14. I'm going to make sure that I round this. But down here, I'm going to just type in these numbers. Like on my formatted one, I'm going to make it look a lot nicer. But these would be my data values. And then over here, I'll just type this in. So I'll do equals STDEVA. And then I'm going to select the range of that. So I have these guys right here. And I hit enter and I get this. I don't want all those. I'm going to leave the 100th place. So I'm going to go down here and decrease decimals until I get to here. And that's how you calculate it in Google Sheets. And today we're going to talk more about kind of like what that means a little more in depth. But that's what it should look like in Google Sheets. So let me go back to my Google Sheets. And we should get this. So now we're going to apply that to heights. So we're going to open the heights spreadsheet, calculate standard deviation for boys' heights, girls' heights, and both groups. Add standard deviation to your existing summary table. So let's go back over here. And what we should have, what I want it to look like, just do the same thing, is underneath your lower bound and upper bound, we're going to do a normal distribution, just like we did measures of center, measures of spread. We're going to do normal distribution, and we're going to add standard deviation right here. And then over here in this cell, we're going to add the formula for that. So remember, it's equals ST diva and then the range. So this is boys' summary statistics. The boys' height is in column D. So I'm going to do, that's what that should look like. And I also am not going to do, I tried this, I think on standard deviation, you want to just select, because it gave me something different. I think it's because there's different types. There's a population standard deviation and a sample standard deviation, and we're dealing with our sample here. So I'm only going to select the cells that I have. So I'm going to click and drag all the way down to here like that. I think when I did it earlier, it wasn't right before making this video because I had the whole entire deal. I think it was including all of this, and it gave me a large standard deviation, which was shouldn't have been correct. So either way, I want y'all to do that for both boys, girls, and both. Once again, your answers are going to be slightly different than mine because remember, my data is not from this year's data. Okay, y'all are looking at current data from this year's AQR classes. So, but you can check if it's in the same spot. You can look up here or right up here and see that that's ST Diva. What am I doing for boys? This one should be the same thing, but it should be in column E. So whatever E2 through E whatever is for this one, E2 through E60, and then this one is looking at both boys and girls combined. So that's the B2 through B122. Now, it's not going to be the same, so don't just copy down what I said because we can have more than 122 entries or less. So make sure that you're doing this with your data set, not just copying down everything I say. All right. So which group's heights are more consistent and how do you know? Well, let's look at this. We just got done talking about what standard deviation means. It's the average distance away from the mean. And with that, the larger the standard deviation means the more spread out the data is. The smaller it means the more closer together. So you can also think about that as consistency. If the data is spread out more, it's less consistent because it is spread out. If it's clustered together, everything is closer to that middle. It's clustered closer to that middle, so it's more consistent. So if I look here, if I have a standard deviation of 3.2, 3.2 is larger than 3 for the girls. So the spread on the boys for standard deviation is spread out a little more, not much, but it's a little more. And then if I look at that for both of them, that should be expected for both boys and girls to have a larger spread. So this one would be a larger spread standard deviation for both. Girls would have the smallest standard deviation. They would be a more narrow curve, and the boys would be not a lot wider than the girls' standard deviation, but a little bit more. And then both of them combined would be more wide than that. So let's talk about how to actually sketch the normal distribution so we can visually see it. I feel like whenever I kind of learned this was kind of what got me to really understand this. The word standard deviation, all the vocabulary you hear is just words, and sometimes the pictures really help. So for each group, we have boys, girls, and both. We're going to start by drawing a bell shape, place the mean in the center, and we're going to label 3 standard deviations above and below the mean. Let's see if I have this on here. I don't. So I'm going to have to do this on this. Okay. So let me go back to this. Okay, I had to pause my video and do this because I thought I had it done, but once again, I didn't. So we're going to start by drawing a bell shape. You already have a bell shape sketch for you in your notes, but you're going to have a big poster sheet of paper, and you're actually going to make 2 of these based off of your research question. So you don't have to do, like, you're going to do all 3 just for the practice and stuff in your notes, but you're going to create 2 for your project, kind of a side by side or whatever. And then we're going to start with, once we have our bell, we're going to we're going to draw a line directly in the middle of our bell. to represent the mean, and we're going to label the mean. And then we're going to label 3 standard deviations above and below the mean. So that's going to give us the average distance away from the mean, and this is kind of what that's going to look like. So it's going to be spaced out kind of like how I have. So here's my curve. I'm going to start with boys, and what I need to know to be able to sketch this, I need to know the mean and the standard deviation. And I'm going to start with drawing the standard deviation in the middle and labeling that at 70.1. So when I say sketch 3 standard deviations above and below the mean, we're getting an idea about where the distribution falls. The closer we are to the mean, right, the more we expect to be there. Because that's where the majority of our data lies. And the further we get in terms of standard deviations, the less likely it is to happen out there. So 1 standard deviation above the mean, what we do is we just take our mean and we add the standard deviation. So we do 70.1 plus 3.2, and I'm going to put a line kind of like about right there. And so this is the math that I'm doing, and I'm going to label that number right here. So we would say 73.3 inches is 1 standard deviation above the mean, is kind of like how we can word that. And we would say above because this is on the right side of the mean. And now we're going to label, this is just 1. Now we're going to do a total of 3. So that we're going to try to evenly space these out as much as we can, where we have our third one kind of down here in this little tail area. So this is my second standard deviation line. I'm going to find out what that value is by adding the 73.3 now. So that number plus the standard deviation. And then I'm going to do one more line. And now I'm going to do 76.5 plus the standard deviation to figure out what that value is. So, and we should be able to look at this, like if you think about this, this is talking about boys. So our maximum boys height was 78 inches. So look at this in terms of like likelihood and chance happening. So what is, and how many people in the population have a height like that? If we look at our graph, as we get over to 79.7 inches, let's see, that is, if we put this in perspective and you think about like just guys, how many guys do you know that are almost 6 feet 9 to 6 feet 9 or 6 feet 10? Because that's roughly what this is saying. And we should expect this number to go out further and further as these heights get larger and larger. We should expect there not to be many people in those areas. You don't see a whole lot of people that are 6'9" or 6'10". If we go another standard deviation, which we only are going to label 3 above and below. But if I were to go another one, let's see what that would be. That if I'm evenly spaced that, so that would be kind of about right here. That's 82.9. So so I misspoke. Like 79.7 is almost 6 feet 8. I think I said 6 feet 10. If we were to go another standard deviation above that, that would be about right here. That would be 82.9, which I mean we can say that that's 83, which is 6 feet 11 inches. So trying to visualize what's happening here in terms of like the higher the bell, the more people we see in that height range. The further we go off into the tail ends, the less amount of people. Like I don't know anybody that's 6 feet 11. I've probably seen some guys like out and about having to duck their head through a big door or whatever, but there's not a lot. So that would be 3 standard deviations above. We're going to do the same thing going below. And we use that starting same with the mean, but now we're going to go below the mean. So we're going to subtract the standard deviation each time. So 70.1 minus the standard deviation of 3.2 gives me 66.9. Then I'm going to take 66.9 and subtract the standard deviation from that to get 63.7, and then do the same thing to get that. So, and once again, going the other way, like this is like this is basically 5 feet. Like, not a lot of guys, especially like young men and adults, are 5 feet tall. Do they exist? Yes. And then thinking about the ones that are shorter than that, same thing. All right, so that's the guys. I'm going to talk a little more quickly through the girls since I've already done one kind of going through, but we need to know the mean and standard deviation. We're going to label the mean in the middle. We're going to go up 3 standard deviations by adding the standard deviation each time we do a mark, and we get that. And then we need to get really comfortable with doing this part. This is going to be the next several days. I'm going to have y'all say, hey, this is what you need to label each time, but we're going to do something different with it. So we need to make sure that we get this part. But we start with the mean, and then we just label 3 standard deviations to the right, 3 standard deviations to the left, or I should say above and below the mean. And we do that just by adding the standard deviation each time to the number that we calculate. And we add it, or if we add it when we're looking to the above the mean, and we subtract it when we do it from below the mean. When I look at both of them together, same thing. 67.3 goes in the middle. I add that with the standard deviation of 4.2 to get 71.5, and so on and so forth. And then on the other side, below the mean. So looking at this example right here, I would say, I would look at this graph and I would say the 67.3 is the mean, 71.5 is 1 standard deviation above the mean, 75.7 inches is 2 standard deviations above the mean, and 79.9 inches is 3 standard deviations above the mean. Going to the other side, I would say 63.1 is 1 standard deviation below the mean, 58.9 is 2 standard deviations below the mean, and 54.7 inches is 3 standard deviations below the mean. So, and then going back to kind of just to show this definition one more time. So once again, going back to this definition, the standard deviation tells us the average distance that data values are from the mean. So the further we go out, we would expect like less values to be out there. Okay, so let's go to, where were we? Okay. So let's see if we can put this kind of in context. Suppose you earn an 80 on your AQR test. If the class average, the mean is 75, would you prefer a standard deviation of 2 or 10 for bragging rights? In other words, which one looks better? So think about standard deviation, right, as it's talking about consistency. So we're going to start by sketching out and labeling the mean and 3 standard deviations above and below for each scenario. So here's our graph with 3 standard deviations. We have 7 lines total. The one on the left says their standard deviation is 2. So we're going to start by putting 75. Our mean is in the middle, and then we're going to count by 2s going to the right and subtracting 2s going to the left. So we get something like this. And then on the right side, we have a standard deviation of 10. I like using this example because I think it helps visualize what standard deviation is. So if you actually made an 80 on your test, where would that fall in each one of these? An 80 would be right here, and 80 would be right here. In this case, which one of these looks better? If you were to go home and you were to talk to your parents about how proud you were for your 80 on your test, which one of these would you say is better for bragging rights? Well, the standard deviation of 2, look how high above the average you were. Not many people did that. Like, you were far above that. And how many standard deviations was that? Let's count. So 77 would be 1, 79 would be 2. It's not quite 3. It looks like if I were to ask how many standard deviations, it's directly in the middle of 2 and 3. So that's actually 2.5 standard deviations. 80 is your grade of 80. Over here, your grade of 80 looks like it's 0.5 standard deviations above the mean because it's directly in the middle of 75 and 85. So if 85 is 1 standard deviation, halfway in the middle of that is 0.5, and you're closer to the average grade anyway. Okay, and your delta math I'm going to need to change, so don't rely on this video for me to tell you what to do on that. But that's standard deviation.